Hi, I'm Chris Teutsch, Forage Extension Specialist located at the University of Kentucky's Research and Education Center in Princeton, Kentucky. I'd like to draw attention to my co-authors, Jessica Buckman and Garrett Hatfield. They are undergraduate students who did summer internships here at this research station, and they worked on this project. The title of our poster today is Impact of Defoliation Height on Crown and Soil Temperature. In 2020, the global temperatures were about 1.75 degrees Fahrenheit higher than the 20th century average. Higher summer temperatures in the transition zone United States may make cool season grasses less well adapted to this region. Changing our defoliation height may help to moderate crown and soil temperatures in pastures and hayfields in this region, enhancing the persistence of cool season grasses. The objective of the current study was to look at the impact of defoliation height on both the crown and soil temperature in an established tall fescue stand. We conducted this experiment at the Research and Education Center located in Princeton, Kentucky. Our experimental design was a random complete block with 4 replications. Our plot size was 10 by 10 feet, and we used an established tall fescue stand for this particular study. Our defoliation treatments were 1 inch weekly, so every week the plot was defoliated to 1 inch, 4.5 inches weekly, or 4.5 inches monthly. We monitored crown and soil temperatures every 15 minutes using data loggers. Our crown sensor was placed in the crown of the plant right at the soil surface. Our soil sensor was placed 4 inches below the soil surface. We used a pivot table to calculate daily minimum, maximum, and average temperatures. And then that daily temperature data were analyzed using general linear model procedure from SAS. I'd like to take just a few minutes and look at some of the data. This is figure 1. And the 1 inch defoliation height is represented by the red line. The 4.5 inch defoliation height on a weekly basis is represented by the green line. What I want to point out to you is that on hot days, we sometimes would exceed a difference in crown temperature of 10 degrees Fahrenheit just due to defoliation height. This is a pretty important finding. A 10-degree difference on a hot day can really impact the amount of stress on that plant. When we looked at the crown temperature, and this is the minimum daily ground temperature, our defoliation treatment of 4.5 inches weekly had the highest minimum crown temperature. When we looked at maximum crown temperature, it had the lowest maximum crown temperature. What these 2 graphs are telling us is that leaving a little more residual in that pasture helped to moderate that crown temperature, so we didn't have the high ends of a minimum and maximum extremes. We looked at average. On average, the 4.5 inch defoliation treatment, leaving more residual in that pasture, had a lower average crown temperature. So let's now take a look at the impact on soil temperature. So it's the same general trend as we observed for the crown, except it's more moderated because that sensor was located 4 inches below the soil surface. Again, we see that same general trend here, although it was not significant for minimum daily soil temperature. The maximum soil temperature, again, was lower with the 4.5 inch treatment. And the average soil temperature was lower with the 4.5 inch defoliation treatment. So leaving that more residual height helped moderate both ends of the extreme in terms of the maximum and the minimum daily soil temperature. Okay, I just want to finish up with a few key findings, and that is the 1 inch defoliation height increases daily crown and soil temperature. After approximately 1 month of close and frequent defoliation, we saw a shift in botanical composition of those 1 inch plots away from the cool season grass towards crabgrass, which is a warm season annual grass. Commonly see this in pastures. So pastures that are grazed hard during the summer months, starting in June, July, and August, commonly have a higher component of summer annual grasses, such as crabgrass, in those stands, because we're putting that cool season grass at a disadvantage by that close and frequent defoliation during the summer months. Rotational stocking could moderate both the crown and soil temperature in pastures. In maintaining a height of 4.5 inches may help cool season grasses to persist during hot summers in the transition zone. And that would hold true for both pastures and hayfields. Thanks for taking the time to watch this presentation. If you have any questions, my contact information is on the bottom of this poster.